the distances, and what are the two approaches that we use in hierarchical clustering. So before going into the detailed part of hierarchical clustering, we can have number of things like what could be taken in account while using clustering, right? So we know that clustering is an unsupervised machine learning technique, right? And over there we don't have a labeled data set, we have unlabeled data set, and we are going to analyze, we are going to segregate the data uh, by by using unlabeled data set, by identifying the patterns in the data, right? What are the patterns, and according to that we are training the machine, like if this could be the pattern, then this would be falling in this group. Like suppose I would say, like you have Amazon site, or you may have any website that is basically categorize the items into multiple groups, right? And then according, like if you talk about electronics, all the electronic items are segregated into one group. And if we talk about your like suppose I am talking about clothing, or you might be having another thing, like you have within electronics, you might be classifying into number of other groups, like it could be mobile, it could be TV, and so on, right? So over here, like we can see the like how it segregates. We don't have the pattern that is any wire or this kind of thing in the clothing, right? In the clothing uh, group, right? So electronic group has its own patterns in the data, whereas clothing has its own pattern in the data, right? So based on those patterns, we basically make the clusters, we basically make the groups out of it, right? So let us begin with the first part. Let us start with this, that is hierarchical clustering, right? So here when we talk about hierarchical clustering, it is the hierarchical decomposition of the data based on group similarity. So what I told you, like if we have some similarity, like if we are talking about clothing, so we have all the components, all the things in that particular group which are basically not of any electronic type, right? Or not of any plastic type. You may have another thing, that is you have your cookware items, right? So that is again one group. So this is how we segregate it, right? So always try to have the real time examples, so that you can connect with the type of clustering, right? So like how we segregate into one group, how we segregate the groups, and how we have the collection of items in one group based on the patterns in the data, right? Based on the features of that data, based on the characteristics of that particular data, right? So here we are going to use two methods. The two top level methods for finding these hierarchical clusters would be agglomerative clustering. Let us understand this thing, and I will be showing you how we make dendrograms out of it, like using either you can use agglomerative or divisive clustering. We might be using any of them, right? So while using agglomerative clustering uses a bottom up approach, wherein each data point starts in its own cluster. So what we do in bottom up clustering, you have one data item, then you check out the distance with other data item, then you make a cluster out of it, and then again check out the distance that particular cluster with some other data point, and this is how you are greedily joining the different data points, right? These clusters are then joined greedily by taking the two most similar clusters together and merging them. So what we do is, the like they are falling into one particular part, so we may take it as a one cluster, right? And this, it is basically a bottom up approach, right? Whereas when we talk about divisive clustering, uses a top down approach wherein all data points start in the same cluster. You can use then a parametric clustering algorithm like k-means to divide the cluster into two clusters. For each cluster, you further divide it down to two clusters until you hit the desired number of clusters, right? So let us see how agglomerative and how divisive clustering is going to work, right? Suppose I am having this graph over here, and in this graph what we have, the first approach, that is agglomerative, right? We have bottom up approach. While we are using agglomerative approach, that means we are following bottom up approach. And if we are talking about divisive approach, we have all the components, we have all the data points, and then we are dividing when we are making the hierarchy of clusters, right? So this is how it works. Let us see one by one how does it work. So first of all, we will be talking about agglomerative hierarchical clustering. So here we have already seen, like when we talk about, there are number of data points and how these data points are segregated. So over here, like how we make dendrograms, that is very important point, and I will be giving more examples of dendrograms. First we will understand how we visualize it and how we make it, how we basically prepare that dendrogram. So the hierarchical clustering technique can be visualized using a dendrogram. A dendrogram is tree-like diagram that records the sequences of merges or splits, right? A cluster at level I is the merger of its child cluster at level I minus 1. So here, like if we are given with this particular graph, right, or you may say this is my data points that are falling into this. So we will be checking out like B is most nearer to C rather than D, right? So that's why we have made this one cluster. And then D and E are most nearer than F, because F we found if it is in between them, then we can say that. So now we another cluster, we make it like this, right? And then we have F part. F is nearer to this, or BC, it is nearer to this part, so we make one cluster. And once we have made all the cluster, A is neither nearer to BC group or F group, right? It has the same distance, so we make a single cluster out of it. And let us see how we make the dendrograms. So over here we can say that the first cluster would be BC. So you have made, first of all, you have clubbed two data points, that is BC. Now another at the same level we have the DE also, right? So over here you can say that there are 2 points, that is D and E, right? And here we make one hierarchy over there, right? And then we have F. So F is not nearer to BC, it is nearer to DE. So what we do is we make like this, right? So then we have another part, we have merged. Let us first of all merge the two clusters, that is these two clusters, BC and EF. And then because A is not falling in neither of the groups, so you are making as this, like this. So this is how our cluster is to be made. Basically dendrogram is to be made for such visualization. So let us see numerically also, like how we are going to solve it. So initially data point is considered as an individual clusters. So you are not taking it into any cluster, you are taking it as a data point. At each iteration, the similar clusters merge with other clusters until one cluster or K clusters are formed. So the basic algorithm would be compute the proximity matrix, let each data point be the cluster, repeat, merge the two closest clusters and update the proximity matrix. I will be telling you how we may update the proximity matrix and how does it works until only a single cluster remains. So before any clustering is performed, it is required to determine the proximity matrix containing the distance between each point using a distance method. So then the matrix is updated to display the distance between each cluster, right? The following three methods differ in how the distance between each cluster is measured, right? You might be having a single leakage, you might be having a complete leakage, and you might be having a average leakage. So you can have any of the method while combining these clusters, right? You may use any of the cluster. Minimum is used, you might be using maximum is used, and let us see how does it work. So here, over here we have agglomerative hierarchical clustering technique. In this we are going to have the first approach, that is single minimum linkage. So distance between the two closest members of two clusters. So there would be two different clusters over here. This is my cluster R and this is my cluster S, and there are two different data points over there, and which has the minimum distance, right? So in singles linkage you are checking out the same minimum distance between them, and then you make a check out the single linkage between them, right? So here next would be your complete linkage, where you are finding the maximum distance between the two data items of two different clusters. So over here we have two clusters, that is R and S, and then we have different points over that, and then we check out, rather than having this single linkage that have the minimum distance, we are taking the we are applying the second approach, that is complete linkage, and maximum distance is used. So you are going to find out the two data points which have the maximum distance between them. Then we have average linkage. It involves the average distance between data points in one cluster to every point in other cluster, right? So here, over here, we are going to have an average linkage, which basically gives you the two clusters, that is R and S, right? And over here, like we have one data point, we have another data point, and we can have the linkage between both the data points. So average distance, we are average distance between each point in one cluster with to every point in other cluster. So this is how it is like associated with other data points in the clusters, right? Then let us perform some numerical over there, like how it does it work actually. So here we have the data point 7, 10, 20, 28 and 35. So then we calculate the minimum distance out of it. We have 3, we have 10, we have 8 and we have 7, right? So the minimum distance over here is we have 3 and 7. So we have made one cluster out of it. Minimum is this one. So we have made the two elements, two data points into one cluster, and then again the same procedure will be followed, like you have 20, 28 and 35. Then you find out the distance between the two of them. You have 10 and 20 and then 10, then 8 and then 7. Again this would be having your minimum distance. Then you are going to club it like this, and then you have made 10 and 8, and over here we can have a cluster of, again the minimum would be this, so it would be falling in this cluster, and we have make the dendrogram for this. Like first of all you have made 7, 10, and then you have made here 28, 35, then you club it with 20, and the two clusters like this cluster and this cluster would be combined. So this is how our dendrogram can be made out of it, right? In the complete linkage part you might be having the same procedure, but here we are going to combine with the maximum distance out of it. So here what we have is 10 is the maximum distance, so we have clubbed it like this. 10 and 20, so it would be like this. We are clubbing with the first part, that is 7, 10. It is clubbed like 7, 10, and then we find out the distance. 7 minus 20 would be your 13, and then we have 28 minus 20 would be 8, and 35 minus 28 would be 7. So here what is my maximum distance? That would be like this. So here also we are going to find out the minimum and the complete linkage. Complete linkage is basically taking out of what? The maximum distance between the two data points, right? So let me, before moving into the next part, let us understand the dendrogram parts also, like how we make the dendrograms. Like suppose you have a data point here, 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 here and here, right? So nearest, first of all we will check out the nearest distance between two points. So here, here, you may say first of all we will be having E and F, right? We make a hierarchy out of it, and then at the same level we have A and B also. We are clubbing it with this also, and then we have D point. which is nearer to this rather than it is nearer to C. So we have clubbed the D point as well. And then we have C point, which is basically falling under this cluster. Why? Because this would be much far from these two data points, right? So that's why we have merged the C data point with this cluster only, with this hierarchy only, and then we overall hierarchy is to be made, right? So next point is, let us take another example out of it. We have these number of points. Let us see how it works. We have EF, we have IJ, we have JK, IH, JK, G, and C. Let us make the dendrogram for it. So first of all, E and F are the nearest point. We have clubbed it as one. Then BC are the nearest point. We have clubbed it as a one hierarchy, right? Then we have IH, make one hierarchy. JK, make one hierarchy. So almost all the elements which are nearer to each other, we have made the hierarchy out of that, right? Now let us go for the nearest data points. This cluster is nearest to which type, which data point? So C would be my nearest data point. So C would be like this. You will be having this part as again C1, take it as C1 and club it with this thing, or take it as G, right? Because it is not visible, so say take it as C1 only, C1, and then we are combining it with here, right? And A, we know that it is almost we can see that A is not nearer to this cluster. Obviously A is nearer to this cluster, so we have combined A over here. And then we are combining the hierarchies of two clusters, and then we have G point. G is again nearest to this hierarchy. Then we are making the two, like they are more nearer to each other rather than this, so we are making one hierarchy for these elements, and we are making the the next hierarchy for these elements over here. So here we have one hierarchy, and this is would be my one hierarchy of cluster, this would be my second, and then we are combining as a whole. So this is how dendrograms are made, right? Now let us take one more example out of it. So over here we can have P, Q, S, U, and T and R. Let us start with the first 2 points. These are two nearest points, so we make hierarchy like this. Then S is almost nearer to U, right? And R is also nearest to these clusters. So first we combine S part and then we combine it as R. PQ are again two clusters and then we combine it with the this hierarchy. So this is how our hierarchy is to be made. Like you have 2 points, then we clubbed it with S part, right? Then we take this data point also, and this is another hierarchy of clusters. So we can combine it with this hierarchy. So this is how we can make dendrograms. We can make dendrograms out of it. Let us move to the next point. So how it works: agglomerative hierarchical clustering examples. Let us see with a single link technique. So you will be using an Euclidean distance method for it, and if you are using single linkage, so minimum distance is taken out of it, right? So here we have 2 points, right? X and Y. So this is our x-axis and this would be our y-axis, and then start plotting the points. So over here P1 is plotted like this: P 0.4 and 0.53, 0.4 from x-axis and 0.5, so this would be my P. And then P2, take the P2, 0.2, 0.3, 0.2, and then we have 0.22 something like this, right? And then we have 38, so here somewhere else, right? Then we have 3.5, so here somewhere, and in the next one 3.2 somewhere here, right? So you have P3, and then P4 0.26, so 0.26 over here, and then we can say that 0.19, so 0.19 would be like here, right? And then we have 0.08, so somewhere here, and then we have 0.41, right? that then we have 0.45 and 0.3 over here. Okay, so this is how our points are to be plotted on the graph. And let us see uh, how it works. Agglomerative hierarchical clustering example. So calculate Euclidean distance, create the distance of matrix that you have x and y, a and b. You have the Euclidean distance method, right? So Euclidean distance, we know that it is x minus a whole square plus y minus b whole square under root. So this is the formula for Euclidean distance method. You can use in this also, and you might be using this in k-means clustering also, right? Like centroid clustering also. So here what we have 2 points. Let us see how it works. We already seen this graph, right? Now find the minimum distance from matrix. So let us find out. So over here we have first of all we make the diagonal elements, and then we take out the one by one we are going to find out. So here we have taken the 2 points as 0.4 and 0.2 and 0.4, and so we are calculating between these two the distance between P1 and P2 we are finding out. So P2 and P1 we have 0.23 distance, right? And then we have P1 say we are calculating with P3, and then we have P4, P5. So P3 has the minimum distance out of it, right? So P3 over here we can see that P3 has the minimum distance. In the next part again the same procedure will be followed, and you will be calculating the distance like P2 with P3 and P2 with P4. So here we can say that it is you may say it is nearer to 0.25, right? So here again you are first of all like how you are going to cluster it. First of all you calculate the distance of all the data points, right? Like P1 say you calculate with all the data points, P2 say you calculate with these number of data points, and after this once you have calculated all the data points, then check out the minimum out of it. So over here we can say that this is P3 and P6 has a minimum distance between them, so we have make a one cluster out of it. This is how you are going to work, right? Let us say another example like how you are going to update the distance. Now your distance would be like this. So here what we have done, we have taken minimum distance and distance between P3 and P6, because here we have seen P3 and P6, and then we take out the distance with P1, because again we are calculating all the distance. Again the same procedure will be followed. You are going to take P3 and P1 and P0 and P1. So you are taking with P1 with every point, right? Then calculate the minimum distance out of it. So you have calculated with the points which are basically the same method will be followed. Like you are putting the zeros over here, and then we have P1 with P2 and P1 with P3 and 6, because this would be my one cluster and this would be my another cluster. So here what we can have is like you can check it out, 0.14, right? It is having the minimum distance from all the data points, right? It is the minimum distance from all the data points. So you are going to make the cluster of P2 with P5. So another cluster would be P2 and P5, and one cluster is already made, P3 and P6. P3 and P6 we have already made, and over here what we have done, again the same procedure we have followed. You have P3 and P6 one dendrogram, and P2 and P5 another dendrogram, right? So like whatever, like you are segregating it now, like you are making any one, calculating one distance, and then at the same time you are going to make these dendrograms, right? So you are going to make the dendrogram at the same time. Like over here when we have made this part, we have made two clusters out of it. Let us take the another one. When we have clubbed it with the whole cluster, we can have the distance because we are finding the minimum distance here. So what we have done, P2, P3 and P3, P6, right? That would be falling under one cluster. So this is how we have taken it as in one cluster. So this would be my dendrogram, wherein I am having one cluster this, and then we are combining the whole cluster out of it, right? Let us take the next part. Let us move to the next part. Now we are combining. This would be my distance. Then you are segregating. Then you are defining the distance with other points. Then you include the P4 with it. So now you have clubbed the P4 with this particular cluster, right? And then you find out the minimum distance. Then you make this point with P1 also is getting added to this particular cluster. So this is how we are basically finding the distances using Euclidean distance method, and then we apply it. Advantages. What are the advantages of hierarchical clustering? No prior information about the number of clusters are required. Easy to implement and gives the best result in some cases. So what are the disadvantages? Algorithm never undo what was done previously. Yes. So once you make the cluster, you cannot go out of it, right? Time complexity. Yes. It takes number of, it takes more time because it would be a complex one when you are calculating each distance. Based on the distance matrix chosen for merging different algorithms can suffer with one of the following methods. Sensitivity to noise. It might be possible there are some outliers. Breaking large clusters. You are breaking a big cluster into that. Difficulty handling different size clusters and convex shapes. No objective function is directly minimized. Sometimes it is difficult to identify correct number of clusters by dendrograms, right? So this is how we are going to implement our data points and making the dendrograms out of it, right? Like how we segregate the data points into clusters, right? How we segregate our data points into clusters. So hope you have understood the session. Hope you like the session. Thank you.